Assalamu alaikum everyone. In the last lecture video, the video number 04, we were discussing the chemical reactions of alkenes, and we studied the combustion reaction of alkene, which was similar to that of alkanes, and then we started with the addition reactions of alkenes, where we studied the hydrogenation, which is addition of hydrogen, hydration, which is addition of steam, which results in formation of alcohols from alkenes. Then we studied halogenation. We took example of bromine water, and then in the last we studied hydrobromination, that is a part of hydrohalogenation reaction, in which the alkene converts into halogen containing alkanes known as alkyl halides. Today we will be looking into the mechanism for the addition reaction of alkenes. This is AS level 9701 chemistry lecture video number 05. The topic for today is mechanism for the addition reaction of alkenes. The journal name for this mechanism is electrophilic addition. So I'll be taking example of the last reaction where we ended lecture number 04, that is hydrobromination of ethene. Hydrobromination of ethene. Now, if you are watching this video on YouTube, there is an option for, you can call it, what I'm speaking, you can look it in your subtitles. So if you can go on the right side corner, there is 3 dotted lines. If you're using an Android phone, I have an Android phone. So it says captions. So just autocorrect that captions option, open it, and then you can see what I'm saying in the written form. That will help you to write your notes. So hydrobromination of ethene, the chemical equation for this reaction is ethene C2H4 reacting with hydrogen bromide. The reaction do not require any specific conditions. It takes place easily at room conditions. The product is C2H5Br. The name for this compound is bromoethane. Now we'll be discussing its mechanism. I'll be drawing the part of the alkene which do not change during the reaction. It's the sigma bonds in ethene. So there is one sigma bond between the 2 carbon atoms, and all the bonds between the carbon and the hydrogen are also sigma. So everything drawn in red is going to be remaining to be unchanged during the reaction. The part which I'm drawing with the green color, this part, which is the pi bond, that is the part which is involved in the reaction. Now let's again go through it, why the pi bond is involved in this reaction. Because imagine a hydrogen bromide molecule coming towards an ethene molecule, because chemical reaction only occurs when the reacting particles collide with each other. So the sigma bond is in the center and the pi bonds is around it. If you remember the diagrams which we studied in chemical bonding, that how the p orbitals are around the sigma bond, and the bond energy to break the pi bond is much less than that of the sigma bond. So it is the pi electrons which first interacts with the hydrogen bromide molecule instead of the sigma electrons. So sigma electrons are these red ones. They are not facing the hydrogen bromide molecule. It is the pi electrons which are going to first interact with hydrogen bromide molecule. Now few important terminologies which those of you who are studying organic chemistry S level for the first time after your O levels, you must not be familiar with, and I have to first make those terminologies clear to you. Now this region of the molecule contains the most number of electrons. Like compared to this area where there is only one pair of electrons, in this area there are 2 pairs, that is total number of 4 electrons. So the electrical charge over here is 2 times 1.6 into 10 raised to power minus 19 coulomb, that is the charge of 1 electron, compared to this area, the electrical charge over here is 4 times 1.6 into 10 raised to power minus 19 coulomb. So this area is more electron dense, it contains more negative charge compared to any other region of the molecule. So what does this mean? This means that this area, which is negatively charged, highly negatively charged, will attract anything which is positive. Now, when we study general science, we know that the opposite attracts, the plus attracts the minus and the minus attracts the plus, the like charges repel. But in organic chemistry, they have their own terminologies to everything. They love making things harder for you guys. So, how to go about this? A region which you are considering to be highly negative obviously attracts positive. So they are going to call this region, from attract they call it philic. Now philia and phobia are normal English terms. Phobia means hating or repelling, philia means loving and attracting. So philic means attracting something. So because negative attracts positive, so instead of calling positive philic, they call it nucleophilic. Because inside the nucleus there are two particles, protons and neutrons. Neutrons don't carry any charge, so protons are positive. So nucleo-attracting means proton attracting, that means positive attracting. So in simple terms, this area is nucleophilic, that means it will attract anything which is positive towards itself. Now what is positive in HBr? In HBr there are two electrons shared between the hydrogen atom and the bromine atom. Bromine atom, being more electronegative, pulls the electron cloud towards its nucleus. Due to this symmetrical distribution of electron cloud, the bromine atom is more partially negative compared to the hydrogen atom, which becomes electron deficient. Now that is the positive which this nucleophilic center can attract. So when you study normal chemistry, you call positive if there is a charge, if this is not an actual charge. If there is a charge like Na positive and Cl negative, you call a positive cation and a negative anion. But in organic chemistry, the positive, because positive attracts negative, they call it electrophile. Again, the term phile means attracting, electro means negative. So this is something which will attract negative because itself is positive. So guess the name for this one. Because it is negative, this must be positive attracting, right? So let's try to give it the name the way they want it. We're going to call it philic because of attracting, because it is negative and it will attract positive. So we are going to call it nucleophilic, like this one. So positive substances are called electrophilic, negative are called nucleophilic. This has nothing to do with the mechanism. These are just general terminologies. Let's start with the mechanism now. So focus over here. In organic chemistry or anywhere in science, the electrons, they move. Just give me a minute. How much? Yeah, 8 minutes. Okay, it's okay. Thank you, sorry. So in organic chemistry or anywhere in science, the electron moves from a region of higher concentration to a region where they are electron deficient, like in a battery. In a battery, the electrons comes out from the negative terminal because that is the place where they are stored, they are in high amount. They move towards the positive terminal because positive terminal is electron deficient, so there is an electron moving force. That same happens over here. If a region which is highly concentrated in electrons, which we call nucleophilic, comes near to a region which is electron deficient, we call electrophilic, the electrons from the negative region flows towards the region which is electron deficient. The curly arrows means that the electrons flows from this region to this side, and this arrow means there are two electrons moving. That means the electron dot, which belongs to the left carbon, and the cross, which belongs to the right carbon, both flows towards this hydrogen. Now when the these electrons comes near to this hydrogen, they push these electrons because electrons repel electrons. They push these electrons away. more towards the bromide nucleus. So imagine these electrons being pulled towards hydrogen and then these electrons being pushed towards bromine. So imagine this double bond pulling hydrogen towards itself, simultaneously pushing bromide away from it. That means this will help in breaking this bond. Now this bond will break heterolytically because it is between different atoms and this bond is a polar bond. That will result in this electron, which actually belongs to the hydrogen atom, going towards the valence shell of the bromine. In the next step, there is an intermediate formed. As I mentioned that nothing happens to the structure drawn with red. I'm drawing it as it was. I'm just shifting this hydrogen from here to here for you to make it easy. Now imagine this bond breaking from here and shifting over this side, like here. It still carries its own electron, this carbon, but also the electron from here, this carbon has shifted over here because it has made a bond with this hydrogen atom. And hydrogen atom has given its electron to bromine. Bromine belongs to group 7, so it has 7 electrons. 1, 2, 3, 4, 5, 6. These are the paired electrons. This is the unpaired one. And 1 electron it has gained from hydrogen. That makes it an anion. This electron is being gained. Because this carbon has lost its electron and it has come over here to make a bond with hydrogen, the carbon carries a positive charge. So the intermediate consists of 2 ions. One is a carbon containing cation, we call it carbocation, and one is the bromide anion. Now again you can judge that what's going to happen because electrons flow from a region of higher value to electron deficient. So the electrons will move from negative to positive. This bromide will make a bond with the carbon. Again, the structure with red remains the same. This dot and cross, oh sorry, I should show it over here. The dot and the cross, hydrogen. This is the hydrogen of HBr, the black one. I'm drawing this bond with black color. This is the electron which originally belonged to hydrogen. It's now over here. This is the electron of bromine. So that's what gives us bromoethane. So just let's quickly go through it again. If you look that if ethene reacts with HBr, the reaction starts because the pi bond of the ethene attacks on the electrophile. That is why this reaction is called electrophilic addition, because it is the electrophile which first involves in breaking the pi bond and adds to the pi bond. It's the electrophile. Now when the pi electron comes near to the electrophile, because opposite attracts, they push the electrons already existing between hydrogen and bromine and helps in breaking this bond, and that creates a bromide anion because the bromide has to gain the electron from hydrogen. Now the bromide attacks on the carbocation. Reminder why this is the carbocation, because this cross belonged to this carbon on the right hand side has now been shifted over here in making a bond with hydrogen. So because this carbon has lost an electron, it carries a positive charge known as carbocation. The bromide ion attacks on this carbocation and makes a new bond over here. So that completes the electrophilic addition. In the next video, lecture number 6, I'll be taking another example of this reaction where there are a few more new things to be learned. Thank you.